Okay. Good morning. Happy Friday. Made it through the virtual week. Sort of. Let's see. Jacob, how you doing, man? All right, seems like you're doing great. I'll just assume you're doing really awesome. Or that you're asleep. Or that you turned on the stream and left the room. Either way. All right, well, to graph system of inequalities. Hi, nice. Okay, hey. Graph system of inequalities. Let's put them in a slope-intercept form. So for the first one, my first move is to subtract 3x from both sides. And then I'll divide both sides by -4. So -3 divided by -4 would be +3/4. +4 divided by -4 would be -1. And then remember, okay, whenever we multiply or divide by a negative, we should switch our sign. We should change the direction of our inequality. So instead of less than, we have y greater than. Right, but let me graph the line. So first off, start with the y-intercept, -1, up 3, right 4, up 3, right 4, or down 3, left 4, down 3, left 4. Since this is strictly greater than, we'll make a dashed line. Right, so that's that first equation. So now let's do the second one. Same thing, let's start off by moving the x's to the other side, or the x to the other side. So 3y greater than 2x minus 6. I just added the 2x. And divide by 3. I don't need to change the inequality sign's direction because I'm just dividing by 3. I'm not dividing by -3. 2 divided by 3, 2/3 x. -6 divided by 3, -2. Okay, oops, that's -3. So -2 up to right 3, up to right 3, up to right 3, or conversely, down to left 3, down to left 3, down to left 3, down to left 3, down to left 3. All right, so this is also so I guess I should probably extend these lines more. I'll extend this blue one more too. Okay, so not a great choice of equations for me. Sorry about that. But now we want to shade, so this second equation became this. we want, since both the signs are greater than for both equations, right? We have greater than and we have greater than. So that means I want to shade above the blue line and above the red line. Okay, so the only reason, so that would be this whole big region here of shading, right? All of this. It's above the blue line and it's above the red line. And that shading works really well. All right, so we just have a couple examples. Our next step is going to be move this into 3 equations, a system of 3 inequalities. Okay, so let's take a look at how that can work, or what that will look like specifically. All right, so let's say I have this system, x minus 2y less than negative 7, 2x minus y less than 4, x plus y less than 2. All right, and let's mix it up. Let's say this middle one is a less than or equal to, just so we have some variety. Okay, so first things first is if I want to graph these equations, I need to put them into slope-intercept form. So I'll take that first equation and subtract x from both sides so that I can move the x over to the right. I'll divide both sides by negative 2. Now remember, when we do that, if we divide by a negative, we need to change the direction of the inequality. Negative x divided by negative 2, so that gives me 1/2 x. Negative 7 divided by negative 2 would be plus 7/2. Okay, I'm going to, kind of like we've done before, I'm going to put little stars here just so I can kind of stay organized as I go through and show that, hey, this is the equation that I'm actually going to graph. All right, let's go ahead and do it. 7/2. All right, so if I want to think about a decimal for graphing, 7/2 is 3.5. So I'll go up to 3.5. My slope is 1/2, so up 1, right 2. Or down 1, left 2. All right, so I have some dots set up. You can do as many as you want. The more the better, just so it gives us a better idea of where the line is. And since it is strictly greater than, we're going to make a dashed line. All right, that's just graphing inequalities 101. And I'm not going to shade just yet. I know my eventual answer should be above this green line, since it says y greater than. But I'm going to wait to shade towards the end. Okay. So next up, let me take my next equation, 2x minus y less than or equal to 4. I'll subtract 2x from both sides. And then to fix that negative y, I'll multiply both sides by -1 or divide by -1, whatever. That will change the direction of my inequality. And then on the right, it'll change to positive 2x minus 4. So I'll graph that. Y-intercept of -4, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or down 2 left 1, down 2 left 1, down 2 left 1. Okay, since for this one I changed it so that it was or equals to, so this should be a solid line. It should not be a dashed line. It should just be a regular good old line. So there's, again, I'll put little stars here just so I can remember exactly what it is that I graphed. So if I need to go back and check something, or it's just good to know. All right, and then lastly, x plus y less than 2. Subtract x from both sides. I don't need to divide anything. I can just go straight to graphing. So y-intercept is positive 2. And the slope is just negative 1. Okay, so don't get confused by that. Just think of it as negative 1 over 1 so that we can kind of imagine the rise over run part. So down 1, right 1, down 1, right 1, down 1, right 1. Or conversely, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Okay, we can just see it's those one box to the next in the corner. And this is y less than, so it should be another dashed line. All right, so I end up with this crazy graph. Now we want to find the area that should be shaded. So there's a lot of different choices. Okay, so there's, let me look at all my options. Right, so there's 1, 2, 3, 4, 5, 6, 7. There's 7 different areas here that could end up being the answer. Right, only one of these areas with the green dots in them are where the solution is, because only one of those fits all of the criteria for each line. Okay, so like this is kind of what it looks like on a PFA, except on a PFA, instead of being a green dot, there'll be a number, and it'll say like which of these areas should be shaded, and you would have to choose, oh, region 1 should be shaded, or region 4 should be shaded, or region 5. Okay, these would actually be listed with a number, not just a green dot. Let's get these out of the way. Okay, so let's look at our first starred equation here. Well, let me also star this one. Okay, let's go back to that green equation. So we want it's y greater than, so I'm going to make a little note to myself. Okay, we want to be above green. Now I'm going to go look at my purple equation. Y greater than or equal to. Okay, so it's greater than or equal to. So we also want to be above purple. And then going to my last equation, the blue one, y less than negative x plus 2. So I want to be below blue. You can go about the actual elimination part to decide the region, whatever, but these are what I need to be thinking. I need to be thinking above green, above purple, below blue. So we can look here. So just being above green tells me it would have to be one of these three. These are the only three that are above green. Okay, well, it also needs to be above purple. Well, that third yellow dot on the right is not above the purple line. It's below the purple line. So I'm going to get rid of that one. That's not an option. So my only two options left are these two, because these are above green and they're above purple. And then the last thing that I want is for it to be below blue. So as I look at these last two dots, only one of them is below blue. All right, so I get rid of that one. So this is the region I want as my final answer, so I'll go ahead and do a really good job of shading this. So this is my final answer. Again, on the PFA, it'll have like a number in that region, like maybe 5 or something. And so you would have to just click the answer that says region 5. It's tricky. It's a little annoying because that means on the PFA that there's a lot of answer choices. This is a multiple choice question that has like 8 choices for region 1, 2, 3, 4, 5, 6, 7, 8. Also, one of the things that you'll see as one of the answer choices so besides just the region numbers, there's also always an answer choice that says this graph is not correct. All right, so it will give you the picture of the lines graphed. So before you start thinking about shading, you first need to make sure, wait, is the equations that it gave me, does that actually match the graph? Okay, because sometimes they don't match. All right, sometimes there's an error. Like maybe one of the slopes is wrong from when you look at the equation and when you look at the graph, so there's something wrong. Okay, so first check to make sure that the lines are just graphed correctly in general. Once you've done that, if they are correct, okay, so you know it should be one of the actual regions shaded, then you can go through and think about the shading. All right, next example. Do you guys think we need a guest lecturer, someone else to come in to do this example for us? From who? I think there's only one obvious choice. I mean, who's the best mathematician out of our entire class? Think about it. Me? No, not me. I think it's pretty obvious who the number one is. All right. So let's bring him in to do some good math for us. He's all the way from the Stanley household, stuffing his backpack with vapes right now to hide them. What in God's name? What? I told you guys Max would show up to the stream. Okay. So let's first think about the first equation. Let's go ahead and change it so that it's in slope-intercept form. Let's also change this first one so that it's less than or equal to. Okay, so subtract 3x from both sides, and then plus 8. Divide both sides by -4. That'll change the direction of the inequality. -3 divided by -4, positive 3/4. Positive 8 divided by -4, -2. I'll go ahead and graph it. Y-intercept -2, up 3, right 4, or down 3, left 4. It is greater than or equal to, so I'll make a solid line. Again, I'll put a little star here. And I'll go ahead and write my comments. So since it's greater than or equal to, so we know the area that we want to shade is going to be above green. My second equation, y less than 5. All right. Well, y equals 5 would be the equation for a horizontal line. All right, remember, y equals makes a horizontal line, x equals makes a vertical line. So since it's y less than, we'll make it a dashed line. Guess let me extend my green line a little bit. Oops, not green. Let's go back to red. It's y less than, so we want to be below red eventually for our final answer. And last equation, so negative 2x plus 7 less than y. So wait a minute. Let me just flip everything around. So this is already sort of in slope-intercept form. I just have to write it so it looks like that. So y greater than negative 2x plus 7. All right, all I did was take the two sides and I turned them around. I switched the sides, and so since I did that, switched the direction of the inequality as well, so that it still stays through the same. So plus 7, 5, 6, 7 is my y-intercept. Negative 2, so down to right 1, down to right 1, down to right 1, down to right 1, down to right 1. It is y greater than, so just a dashed line. It's kind of a poorly drawn line. And thinking about what we want, since it is y greater than, then we want to be above blue. Okay, so everything's graphed. Now let's actually think about the shading. All right, so let's just go through it piece by piece, right? Kind of process elimination style. So for the first equation, we know it needs to be above green. All right, so that gives me more options. All right, so all 4 of these regions are above green. We want it to be, now we also want it to be below red. So that will get rid of this region and we'll get rid of this region because those are both above red. And then for the last equation, we know we want it to be above blue. Okay, so above blue, that would eliminate this. So for this problem, the region that we want is this triangular piece to be shaded in the middle. Could I take systems of equations after this class? Sure thing. All right. Thank you, Max, for coming in and helping out with stream, doing that problem for us. That was demonstrated beautifully. All right, so it's just graphing and shading. Yeah, there's more regions to think about, but no problem. And again, on the PFA, you'll just have to pick the number of the region that should be shaded. But first, check to make sure that the lines are even graphed correctly, because there might be a mistake, and it might be a small one too. It might not be very obvious. So make sure you take the equations, put them into slope-intercept form, and go from there. Questions? What are those? What are questions? An interrogative, style sentence. It aims to gain some sort of information that was previously unknown. Did I do it? Oh yeah, hopefully you guys saw from PFAs, and I can't remember if I said it or not in. I know I said it in my other classes. I can't remember if I said it in your guys' live class about PFAs. So I put it on the update in the email, but when you want to take a PFA, just request it, and I'll accept it. I'm not going to make you do anything. Don't send me anything. Right? I'm not going to make you get in a Zoom conference or whatever. I'll check usually. I check usually like before and after every class that I teach. So no guarantee that I can accept it immediately whenever you do it. It just depends on when it is. But it should be like within 30 minutes to an hour after I'm done teaching. I usually sweep through and approve any that I see. So feel free to go for those and try them out. You don't want to watch us stare blankly at a screen to make sure we don't have a phone hidden in the area. I don't. And you know what? That's probably just I don't. I probably should. But I have better things to do, like take pictures, from the internet and crop out just the head so that I can add it onto my stream and things like that. I'm way too busy with important stuff like that. I'm scared what's next. So you are saying you trust us. No, that is not what I said at all. Is that what you heard me say? Did I ever say that I trusted you guys? No. That is not what I'm saying. But what I'm saying is, I'm also, even though I don't trust you, I'm also not going to watch you take a PFA.